Welcome to all. I am T. Anita, Assistant Professor, Department of Mathematics, SF. In this class, we discuss about open ball in a metric space. Now we see the definition. Let M be a metric space with metric D, and A be a point of M and R be a positive real number. Then the open ball with the center A and radius R is the set of all points x in M whose distance from the center is less than R. The open ball is denoted by B of A comma R. Note that the center is always a point of the open ball because the distance between A and itself is less than equal to 0, which is less than R. So it is always a point of the open ball. So each open ball is always non-empty. Next we see some example of open balls in various matrices. First consider R2 with the usual metric. Then the open ball with the center as origin and the radius is 1 is the set of all points x comma y in R2 such that whose distance from the origin is less than 1. Here the metric is usual metric. So the distance between origin and a point x comma y is root of x minus 0 the whole square plus y minus 0 the whole square. So this ball contains all the points x comma y in R2 such that x square plus y square less than 1. X square plus y square less than 1 represent the set of all interior of the circle with the center as 0 comma 0 and a radius 1. This is shown in this figure. Generally in R2 with the usual metric, the ball B of A comma R is the interior of the circle with the center A and radius R. In the next example, we show that what is an open ball in R2 with the metric D of x comma x1 comma y1 and x2 comma y2. Here the metric is maximum of distance between the x coordinate and the distance between the y coordinate. So the open ball with the center as origin and radius 1 is the set of all points x comma y in R2 such that the distance between origin and a point is less than 1. Here the metric is maximum of distance between x coordinate and y coordinate. So this ball contains a set of all points x comma y in R2 such that the maximum of modulus x comma modulus y less than 1. This is the interior of the square with the vertices 1 comma 1 minus 1 comma 1 minus 1 comma minus 1 and 1 comma minus 1. This is shown in this figure. In the next example, we will see what is an open ball in a metric space R2 with the metric modulus x1 minus x2 plus modulus y1 minus y2. This is sum of distance between x coordinate and the distance between y coordinate. So here the open ball with the center as origin and the radius 1 is the set of all points x comma y belongs to R2 such that modulus x plus modulus y less than 1. This is the square bounded by the 4 lines x plus y equal to 1, x minus x plus y equal to 1, x plus y equal to minus 1 and x minus y equal to 1. This is shown in this figure. From these 3 examples, we observe that the open ball with the same center and the same radius are changes when the open when the matrices are varies. Thank you.